Hello, good evening, good afternoon, good morning to you all from who all are joining us globally. Thank you all for joining us today. We have a disturbance. Okay. Sorry for the trouble. Thank you all for joining us today. I am Parth Varu, event planner for Microsoft Reactor Bangalore. The session will run over next 60 minutes, including Q&A. This session will be recorded and will be uploaded to our Reactor YouTube channel. We will share the link of our YouTube channel in the chat section soon. Before we begin, please take a moment to read our code of conduct. We are all here to learn together, so please be respectful of other people's views, understanding of differences, being kind and considerate in the way you all engage. The chat will be open throughout, and we do encourage you all to participate. Also, please keep your mics muted during the session. I would now like to welcome Sai Prasad, our speaker for today's session. Sai is a Microsoft certified data analyst and has been associated with Microsoft. In his past, he was a champion of project management from PMI India and champion advisory committee, PMI India. He has won Microsoft MVP 8 times. Wow, in a row. Presently, he is working with Cognizant Technology Solutions with 2 decades of experience, and he loves facilitating project management, leadership, and Power BI training programs. Over to Sai to begin the session.
Hey, thank you, Bharat. Hello, everyone. Thank you for spending your evening or early morning joining this session. So we would like to start this session with a question because I do understand many of you have been using Power BI for a very long time. So my question to you all is, what is Microsoft Power BI primarily used for? What is Microsoft Power BI primarily used for? Please share your thoughts on the chat. Monitoring dashboards, okay, reporting, data visualization. What else comes to your mind? Very good. So it's more for generating reports, dashboards, visualization, analytics is what I do see as a very common response across everyone. I would like to give you a different insight about it. Rather than seeing Microsoft Power BI as a visualization product, we also need to accept the fact it is also a very good data modeling product. Because if your data is not cleaned up properly, if it is not quite optimized properly, your reports and your insights will be very poor. And naturally, the performance of your reports are going to suffer. I hope all of you agree with this statement. So rather than seeing Microsoft Power BI as a visualization product, I would also want you to complement the statement with it is also a data modeling product through which you are going to get data from different data sources, mash up that data, clean that data, build relationships on top of it, have calculated columns and measures and relationships there. So today's topic is something very basic for someone who is quite new to data modeling, but a very strong concept because somewhere down the lines when we do data modeling within Power BI space, we ignore these basic fundamental concepts which is naturally affecting the performance of our reports. And naturally, it is going to have a very big impact on the experience your users will have. So I don't have any presentation for today. Rather, this is going to be a complete hands-on with evidences, examples, tips, and techniques so that you can go back and start applying it. I'll be sharing you some reference documents, some videos, which you might want to refer to at the end of the session so that you can continue your learning journey on top of it. So is everyone excited to learn why Power BI loves Star Schema? Can I get your reaction on the chat window? You can give me a smiley. Wonderful, wonderful. So thank you everyone. So let's get started. So first, we will start with the idea of what is basically a star schema. Okay, so I'm just going to go back to my Power BI desktop. So when we talk about the term star schema, right, we are talking about a collection of tables that should be part of your data model. I need to go behind the scenes for you to understand this term data model in case if you are quite new to this term. So think of a data model as a database because technically your Power BI desktop is running an analysis service behind the scenes that creates and manages this data model. So coming back to this term called star schema, it's a collection of tables where each and every table will ideally have a purpose. The reason why it gets a name called a star schema is you are going to have only two types of tables within this data model. One is often called as a dimension. The other is called as a fact. When I say a dimension table, we are talking about business entities. Can I have some examples of business entities that comes to your mind? I'll give you the definition of what a business entity is. These are ideally entities, okay, without which an organization or an ecosystem cannot survive. They are very essential in order to move forward. So look at your own organization. What are certain business entities that comes to your mind without which you cannot run a business? Please use your chat to send them across. Go ahead. Give me some examples of business entities. Okay, so I do see employees, leads, contacts. Okay, what else comes to your mind? Can we say products? Product is also a business entity. Can I say a customer, a client is also a business entity? Category can be a business entity, correct? Wonderful. So when I say a business entities, we are talking about, right, live entities, okay, without which you cannot move forward. So naturally, these dimension tables are going to have attributes about these entities. An example like employee. If I say employee is a dimension, what are certain details that comes to your mind as an employee? It can be your joining date, it can be your skill, it can be your employee ID, okay, and other sorts of details that are attached to an employee. So very similar, every business entity will have its own set of attributes, which together is what we call as a dimension. Then what is a fact? The term fact means truth, measurement. We are talking about measuring something. If I ask you what is the performance of a customer, what is the sales pattern of products? If I look at the customer or the product dimension table alone, we cannot answer that question. So naturally, we need to have some measurement by time. That's what we record in a fact table. So why is this quite important for Power BI and why are we talking about it? You may accept the fact that the data that you get into your Power BI can come from any different data source. It can come from web, it can come from a flat file, it can be from an Excel workbook, it can be from relational database or anything on the cloud also. Certain data sources are already compliant to star schema, so you don't have much work to do on that. But predominantly, when we are talking about heterogeneous data sources, where we have some data that is flowing in from different systems, naturally we cannot guarantee that that data will fall within this star schema. And hence it is very, very important that you organize your data within your data model in a star schema format. So just to sum up, when we say a dimension, we are talking about business entities and its details. When we talk about facts, facts are going to have some measurements about your dimension. For example, with respect to customer, it can have the sales that they made. If you talk about employee, we can talk about timesheet as a fact also. So here is an example for you to understand a star schema. It's not a true star schema in complete essence because we need to correct this star schema later. But as you can see that we are having two dimensions here. One is the dimension on date and another is a dimension on the product. And we are also having the fact table, which is a sales table, through which we will be able to aggregate the sales information or the tax of the sales by either date or by product or a combination of these two dimensions. So why is this important? Because there are a lot of thoughts that will run to our mind. Why can't I have one big fat table which will have all the information of dates, products, customers, and sales? And why to take the headache of having relationships and having so many tables? So I'm going to give you some evidences on what happens behind the scenes with respect to every stage when it comes to report development. Okay, so first let me go back to my whiteboard here. So the question that should come to your mind always is, it's not that you as a Power BI developer are happy about the way in which you create this report. Even your user should be very happy about consuming or interacting with the report. If the report looks quite nice on the screen, but it takes so many seconds to display, naturally the result of the effort that you have spent, okay, is not giving you the reward. So I'm going to talk about four different areas on why the star schema is very, very important. I'm going to look at two data models within a Power BI. One is a bad data model, another is a good data model that complies to your star schema. So first, let's start with the bad one first. Okay, so I'm just going to go back to this data model. As you can see that in this data model, I have only one table called fact sales. Let's examine the fields of this fact sales table. It includes different attributes of sales, like it can be the tax amount, the sales amount. Besides that, it is also having information about each and every attribute about date, like the calendar month, the year, the day of the week, and other details also. So as you see that this is one big fact table, which is even having information about your entity, which is a bad practice, I would say. But some of you may say whether this is good or bad, okay, but you will understand the reason why I'm calling it as bad in another few minutes. I am also having another data model that you have already seen. This is as per your star schema because I have a set of dimension tables like date or product or subcategory through which we would be able to filter your sales table through relationship. So an example here, I can have some visualizations where I would like to see the total sales by product color. So color is coming from my product table, naturally through which I can filter my sales table by the sales amount or by my tax amount. Okay. So the first thing that I want you to focus on when we look at the term called performance, it's not just the report performance alone. You should also understand that every data model will have a collection of data models, a collection of tables, which will fall in one or two of the storage modes. I'm sure some of you would have heard about this term storage mode. So if someone knows about it, can you list what are the types of storage modes available with Power BI? Let's see who's able to get it. What are some of the storage modes? Exactly, Param, okay, so we have the import, we have the direct query, we also have the dual as a storage mode, right? Okay, for those who are not aware of this term called import, when I say an import, the data of that particular table is going to be copied within Power BI. So when you are having a local copy of a data within the local memory, naturally the performance is going to improve, which means your reports that are dependent on an imported table, okay, are going to be rendered very fast. Whereas there are certain tables where you may not want to import it. Why? Because those are tables that will change very fast. Its underlying data will change very fast. An example here. I can say that the date dimension and the product dimension table are going to be relatively static, which means they will change, but not so frequently every second. Whereas if you look at your fact sales table, this is going to have measurements which will change every minute because we'll have some sales every minute, right? So I may not want to import my sales. Rather, I will go for a direct query as a storage mode for my sales. If you need to know more about these storage modes, okay, Microsoft is having very good, great documentations on storage modes. I would strongly recommend you to look into that also. So in this example, I'm using only the import storage mode. So the import storage mode can be identified by these small icons here, which means that the small icon that you see on top of each one of these tables indicates that there is a local copy of all these three tables within your Power BI, which means that you need to refresh this data model periodically. If you are publishing this report to your Power BI service, right, you would have heard of this term called data set refresh, which can be automatic or it can be scheduled also, right? Now, the first part is when you're having tables that are having an import storage mode, it's very important that the refresh is happening very fast because we have some thresholds available here. Because a workspace within which you are going to publish this data model and the report, okay, if it is in a shared capacity, the data set refresh should complete in 2 hours time. But if it is going to be in a premium capacity, it should complete in 5 hours time. So whether it is 2 hours or 5 hours, you need to ensure that your refresh of your imported tables are happening very, very fast. Okay. Now the first step is you need to understand the size of your data model. Because based on the size of your data model or how much memory it is going to take finally, right, your refresh is going to be either fast or slow. So how do I decide or how do I know the size of this particular data model? There are different options available. I'm going to give you some easy methods of doing it. There are certain external tools that you need to install on your Power BI desktop to make it happen. First, we have a tool called DAX Studio. I'm sure all of you would have started using it. So I already have the DAX Studio. I'm just going to click on the DAX Studio on the Star Schema report. Okay. So I'm just going to change the color for you, okay, so that you can read it. So the brighter one that you see in the DAX Studio, okay, is more for the star schema, whereas a black one that you will see in the DAX Studio later is more for the bad data model, that is the fat data model, okay? So how do I know the size of this data model? So you can go to advanced, you can go to view metrics. So this is going to help you to understand how much of space this data model is taking in memory. So let's start with summary here. You can see that this star schema data model is taking around 30 MB of space in memory. Okay. Now let's go back and do a quick refresh of this data model, the star schema data model. So I'll just go to home. I will say we want to refresh it. Now you see that all these tables are going to be refreshed. Okay. So just on August, right, there was a new release. It was made in Power BI desktop. Okay. I'll show you what it is. You can control, okay, how many parallel tables can be refreshed at any point in time. In a shared capacity, the maximum number of tables that can be refreshed simultaneously is 6. Whereas in a premium capacity, you can increase that number. As you have seen that they were simultaneously getting refreshed, which means that it is naturally going to be refreshed much quicker, okay, compared to another data model. So here is a quick tip for you. If you're quite curious to understand how can I increase the number of tables that can be parallelly refreshed when I refresh it within your Power BI desktop or within your Power BI service, you can go to the file, options and settings, options, okay, and go to the current file data load, and you should see the section called parallel loading of tables. The default implies that in a shared capacity, okay, when this workspace is published in a shared capacity, uh, okay, uh, the maximum number of parallel loading tables is limited to 6. Whereas when it is going to be published to a premium capacity, right, you can take control of this custom. But I strongly recommend don't go for custom here, because as the number increases here, which means there's going to be too many simultaneous requests that is going to be sent to one or more data sources, which would ideally add more workload to those data sources. So a better option could be you might need to look at optimizing your data model, okay, rather than uh, looking at increasing the parallel loading of these tables. Okay, fine. So I'll pause here for a moment. I hope all of you are able to follow till this step. Can I have some smileys or yes? I hope we are good. Okay, good. So I'm just taking it as a yes. Okay. Now let's go to the other report, okay, where I'm having a bad design. Okay, so let's get into that. Yeah. So here is a fat data model, okay, where I have only one table. So let's go to the view, the DAX Studio metrics. So I'll run the DAX Studio. I'll go to advanced. I'll say I want to view the metrics of this. I'll go to summary. Now look at the size of this data model, right? It was relatively having the same content, but it is almost double than that. Okay, so obviously you should know the reason why the number is higher. So can someone think of it? It is still the same set of tables, whereas here we have combined all dimension into one single table. Whereas in the other data model, it follows a star schema. Why do you think the size of this data model is higher? Anyone? The number of data items is larger as dimensions are repeated. Joins are happening. It is redundant. Okay, the key term here is redundancy, number one. Okay, and also if you look at it, the term fat, okay, is used is because the number of columns are growing in this particular data model. Okay, which means that your imported tables, okay, are actually being compressed based on its data type and the cardinality of each one of these columns. So let me show you what I mean by this. Okay, so I'm just going to go back to my DAX Studio. Okay, so I'll just use this. Okay, so the one that you're seeing here, okay, the one that you're seeing here is the bad design. Okay, I'm just going to color it differently. Okay, so the black one indicates that this is the fat data model. Okay, so I'm just going to look at the tables first. As you see that we have only one single table, the remaining tables are auto created because of the date time data type. But let's focus on the fact sales here. When you look at the fact sales, look at the total size of this particular table, right? It is much on the higher end. Okay, and what is contributing to this total size? You can see that the total cost is much higher. Okay, the full date table is also contributing. But if you just ask yourself, okay, why should my I would say the date key should have a higher end? The reason is because the same date key or the date description is being repeated so many times in that particular column. So when you're having too many values repeated, okay, within the same column, naturally there should be a high level of compression that should happen. But there is another factor that is influencing this. Though the cardinality is on the lower end, you see that the total size is much higher. The reason is because one of the key aspects for compressing a particular column is not just the cardinality. The term cardinality means how many distinct values I have in that particular column. Okay. What is also equally important for that compression to happen is the sort order of that particular column. So just I want you to just visualize your sales table before you. You know that on the same day, maybe at different points in time, there could be different sales, which means that the date description may not be continuous. Maybe it could be repeated, but not continuous, but at different points in time, which means that the compression will not be so optimal. Okay, so this is something that I want you to focus on. Just look at it. Your full date label, okay, is taking uh, so much. Okay, so let's try to compare this with the one that we are having on the star schema. So I'll go to the view metrics again. I'll go to tables. I'll go to the date table here. Okay, and look at this number. Okay, so it is just 89,000. Whereas if you look at the number that you're seeing here is much higher than what you were seeing earlier, right? The reason is quite obvious. We are having a lot of redundant data. Okay, though the cardinality is on the lower end, okay, naturally the compression will not be so optimal because they are not sorted in the way it needs to be compressed. Because of this reason, right, naturally you need to look at, I would say, normalizing your data. Okay, so when we talk about normalization, it can be done either at your source level, which means that if you are going to get your data from your database or from a different system, naturally you can have tables in this format. Okay, so that you can try to look at reducing the size of your data model automatically. In case if your data source does not supply this information in this manner, naturally you may need to look at using your Power Query editor, okay, through which you will be able to break down your data as dimensions or facts like the way we are just talking about. So here I have the star schema where you can see that the date key is the one that connects my dim date with my fact sales. Similarly, if you look at your dim product and your fact sales, it is being related by your product key over there. Okay, so the first point that we have learned here is, okay, naturally the refresh time, okay, is going to be very important. So naturally in a fact, I would say in a fat data model, okay, naturally the cardinality could be on the lower end, but look at it, optimization would be poor. Whereas when we talk about a star schema data model, okay, naturally the optimization will be very good because you are having fact tables and dimension tables separately. Okay, good. Now let's look at the next aspect of why this star schema is very important as a report author also. One of the primary reasons why we would want to have different tables with its own uniqueness is reusability. Okay, because if you are going to share your data model with others, if I have one big fat data model, it's very difficult for them to know which field to use, how to locate this field, and what is the meaning of each one of the fields if I have only one single table with all information. Rather, if I have different tables like customer or project or client or product, it's quite easy for them to search for it and build their own reports on it. And that's another strong reason that I want to advocate in this case. The third reason, right, which people would often recognize at a later stage in report development is the speed in which the visuals are displayed when you're having a fat data model and a star schema data model. So I don't have a very large data model to demonstrate it, but I'm just going to show you what happens behind the scenes. Okay, when we start executing queries on both these types of data model. So let's walk into that. Okay, so I'm going to go back to my fat data model where I have only one single table. I'm not going to build visuals, rather I'm going to directly start writing DAX queries here, through which you can understand how long does it take for each one of these queries to execute, what type of join does it use if it needs to, okay, and what is the performance of the different storage engines that are being used for getting that result. So if you're quite new to DAX, okay, it's quite easy to learn if you want to start, but I'm not going to teach you DAX completely here. Rather, I'm going to use certain simple options within this DAX studio so that you can start constructing these queries. So if you are using your Tax Studio, I would strongly recommend you to explore the home ribbon first. First, we will start with the query builder. The query builder is a place where you can start dragging and dropping columns and measures. Okay, you can add some filters. You can even configure what should be the sort order by of your result. So we'll start something very simple here. Okay, so we'll just go to the sales table. Okay, the fact sales table. We'll just have the year, the calendar year. We'll drag it and drop it. Okay, and I'll just say I want to update it. Now you see that the DAX query is automatically being built. What this query basically does is it is listing all the calendar years that resides in your sales table. Did I say all? It's not all actually, it is unique. Okay, it is all, I would say not unique, it is all distinct years that are coming from the sales table will be listed here. So let's run this and see what the result is. So I'm going to select it. I'll go to the home. I'll just say run. Now you see that I don't see repetitive values here. I just see only 3 distinct values of your calendar year. Okay. Now what we are going to do next is we will just now focus on how much time did it take to execute this query. It was very fast, right? But I just want you to understand that when this DAX query is being executed on, I would say, on top of your data model, right? There are certain engines that are happening or that are operating behind the scenes to get this result. There are 2 types of engines. One is called as the formula engine. The other is called as a storage engine. The formula engine is the one that will understand what this DAX expression is. It will convert that into different queries. The term query is not a SQL query. Rather, it was going to give you different instructions to the next engine, which is the storage engine, in terms of getting the result. If it is not able to get the result in one single query, it is naturally going to execute different queries on the storage engine, and the formula engine is going to take the responsibility of looping through the data and combining the result and giving it back to us. I know that this might be very theoretical, so let's go back and see how much time was a formula engine and how much time was a storage engine was taking to get this result. So I'm just going to select this once again. But before I run it, right, I go to the home ribbon. I will turn on the server timings. The server timings is going to give you some metrics in terms of what is the total time taken for the formula engine and for the storage engine. Okay, and how much CPU is required, okay, for executing those storage engine queries. So let's run this again. So I'm going to select it. And it's always better to say clear and run, because if this query was executed just recently, it will immediately give me the cached result. Rather, I want to clear the cache before executing this query. So I'll say clear and run. I'll just say run right now. You can see that it was taking 3 milliseconds, very small number, to get this result. As you can see that the storage engine was not even used. So don't conclude that it is not hitting my database or it is not hitting my cache. It is still hitting your cache, but it is much lesser than a 1 milliseconds, and hence it is not quite obviously visible to you. So now let's look at what is a query that was run. So this query that you're seeing here looks like a SQL query for us. But it is not a SQL query. It is often called as a XM SQL query. This is a query that is often understood by your VertiPack engine or by your cache that is having your imported data. So as you see that this is a very simple query, which is just selecting the year from the fax sales. Remember, the fax sales is having an import storage mode, which means it is hitting the cache in memory, but it is not going to your original data source. Okay. Now let's do some small changes to this. Okay, so what I want to do now is, rather than looking at the year alone, we would like to see the total sales, which is a sum of sales, okay, of all the years. So I'm just going to remove these entries here. Okay. Okay, I'm just taking some help from my notepad. Just give me a minute. So I'm basically aggregating the total sales amount, okay, across all the rows in my sales table. So let's see what the result is. Okay, I think I have a problem. Let's see what it is. Am I missing anything here? Yeah, yeah. So it's executed. Now, if you now look at it, it was taking 8 milliseconds to execute, okay, of which 6 was taken by the storage engine and 2 milliseconds is being taken by my formula engine. So remember, the formula engine does not have much work here because this query that we are talking about is naturally going to give the complete result that you want here. Okay, so I'm just going to rerun this so that you can see the query. So you can see that it is the same exact query, but I'm just doing a sum of fact sales of sales amount. Now let's run the same query again, okay, but on my star schema data model. So let me copy this. I'll go back to the other DAX studio. Okay, so this is much brighter. So I'm just going to paste it here. Remember, I have the sales table within which I'm doing the sum of sales amount. So let's run this. Home, clear on run, server timings, and run it. Hmm. So naturally now you can see that it is much smaller here. Okay, but you should not see much difference between these two numbers because the number of rows are still same between the two data models. So the time taken to give you the result will relatively be very, very similar. But now let's try to add a few more elements to these queries. So I'm going to go back to my fat data model. Okay, so now what I would do is I will just want to look at just copy this. Okay, so by year, I would like to do it. So let's have the year, comma, this, which means I want to have the sum of sales by each calendar year. Okay, so now let's run this query. I'll copy this. I will just run this. So now you see that it is taking 6 milliseconds. It is hitting only one single table because this table is having both my year as well as my sales amount. Okay, and it is taking 6 milliseconds. So now let's go to the other one. So I'm going to paste it. Okay, so I'll just copy this in the star schema. I'll paste it. But do remember, my calendar year is not part of my fact sales. It is part of my dim date. So I'm just going to rename this to dim date. I'll change the order by clause, copy this and run it. Now you see that, okay, it is taking 9 milliseconds, which means the one in the star schema is taking 9 milliseconds, whereas the one that you see in the fat data model is taking 6 milliseconds. So this, I would say, cancels the idea that a star schema is good than a fat data model. But remember, these are very simple DAX expressions that we are writing. But as you start writing more complex DAX expressions, right, you will naturally understand why one is better than the other. But the reason, right? What do you think is the reason why the total seconds in my fat data model is 6 milliseconds, whereas in my star schema is 9 milliseconds? Ideally, we are expecting the star schema to have a smaller number. Why do you think my fat data model is taking less time compared to my star schema? Very good. Very good. So I did see some answers coming in. Let's wait. Can someone think of it? Why is your fat data model running much faster? Data aggregation is already done. Okay. Think of that. So in a fat data model, I'll just go back. In a fat data model, how many tables are being used? There is only one table that is being used. I hope all of you see that, right? There is only one table called fact sales. Okay. So which means the scanning time is now going to be reduced because it's only one table. Though we are having a lot of duplicates in the calendar year, but it does not need to jump across tables to get this data. And hence it is much faster. Whereas if you look at the other one, you see that there is a left outer join that is being performed between the sales table and the date table because we have a dimension and we have a fact table here also, correct? This is often called as a table expansion when we talk about Power BI. So table expansion basically means the table on the many side does a left outer join with a table on the one side. In this example, the sales table is on the many side, whereas on the one side we are having the dim date. So naturally it does a left outer join so that everything in the sales table is getting included, okay, with matching items from the date table. So since there is a join that happens, there is a cost associated with jumping across multiple tables, and hence you see that an additional 2 or 3 milliseconds was taken in order to get this result. I hope all of you got it. The relationships between the star schema tables, okay, is the one that is adding time here. Is everyone with me on this? Can I get a yes? Yep. Good. So thank you. Good. Now let's move on to another one. Okay, so I'm just going to remove this. Okay, and I'll just go back to my fat data model again. Okay, now what we would do next is rather than looking at a year, right? Let's try to look at something very odd. Let's say the date. Okay, so we have a date key here. So let's have the date key. Let's update it. Okay, so let's have the hmm. So now you look at it, you're having the date key, okay, and by each and every date, we want to do the sum of sales. So let's run this. I have cleared it. Server timing is on. Let's run this. Now you see that it is taking 10 milliseconds. Now let's run a very similar query. I just need to replace this with dim date and dim date. Let's run this. Now let's start with the star schema first. Okay, so you can see that it is still doing a left outer join. Okay, uh, where if you look at it, we are using the date key for grouping. Whereas in the earlier one, we were using the year for doing the grouping. Okay, since there is a relationship cost here, you can see that it was taking 11 milliseconds. Some of you might wonder, or even having a question right now, is this 11 milliseconds accurate? Can I claim that this will always be the same number every time? So we cannot guarantee that because it also depends on the performance of my system right now. So if you want to understand on an average, how long does this query take to execute? Okay, you can run a small benchmark activity on top of this DAX expression. So I can run a benchmark here going to advanced. So I can say that I don't want to use any warm cache. When I say the warm cache, which means if the result is already cached in memory, it's naturally going to give you the same result. Rather, I want to use a cold cache here, which means that this DAX expression is going to be executed 5 times and it will not use the result of the previous query. So let's run this. So 5 times it's going to be executed so that we can see a true number in terms of how long did this query take to execute. You can see that on an average, it was taking 10 milliseconds to execute, where the minimum is 9 and the maximum is 11. So let's do something very similar here. We'll go to advanced. We will say I want to run this DAX expression on the cold cache 5 times. Let's run this. Okay, so now you see that it is 8 seconds. Okay, I hope you understood the point here. It looks right now that your fat table is much better than a star schema data model, right? But as you start adding more complex DAX measures, right, your story will naturally change. Let's start doing it, okay? So now the next step that I'm going to do is, rather than just using the date key alone, let's also have the month and the year also as a part of your summarize columns. So I'll come back here. I'll just say we would like to have the month, say the month labels, the quarter labels, the week labels. I will update it. Okay, so now let's run this. Let's see how long does it take. Then we will look at time for storage engine. Now you see that it was taking 19 milliseconds to execute. Okay, so now let's rerun this. Okay, with server timings on. Okay, so you can see that approximately it was taking 15 milliseconds to execute. Now let's copy this. Let's go back, paste it here. And I just need to change this to dim date. Okay, so now let's run this. Okay, so you can see that it is much lesser right now. The reason is quite obvious because we are now trying to have multiple columns, which means that the cardinality of each one of these columns are much lesser. So the time taken to execute is also going to slow down. But I hope you see there is a small difference in the number of queries that are executed. Earlier, there was only one query that was executed on your storage engine, but right now you see there are two queries that are executed. The first thing is the common element between your fact sales and your dim date is your date key, or you can see there is a key field that is related. So the first step is it gets, okay, it does the sum of sales amount for all the date keys. And for each of the date key, it needs to find the month label, the quarter label, and the week label, which is what is being done in the next one. So as you see that the formula engine is having some work here because the formula engine is first going to execute the first query. And based on the result, okay, it is going to call the next query with it is going to call the next query. Okay, and based on the result, it is going to combine the result of both these select queries in order to give the result that we want here. Okay, so this is the basic difference that you can find, okay, when it comes to the star schema as well as the fact data model. Now let's add some flavor to it. Okay, so now let's get into the next measure. This measure, okay, is pretty complex. Okay, so I'm going to walk you through on what we are ideally trying to do here. We are going to do a rolling sum. We call it as the total year to date or total month to date. Okay, you might have used these DAX functions. Rather than using those DAX functions, right, I am basically I've rewritten my expression so that we can do it, okay, through uh, simple expressions that you can understand. Now let's first understand what this DAX expression is doing. So this DAX expression is doing a grouping by the calendar year and the calendar month, and we are calculating the total sales within each and every month. So what I mean by each month is, let's say in January we made $1,000. In February we made $2,000, which means for February it should be 1,000 plus 2,000. It should be 3,000, which means that the total sales that you are seeing for every month should ideally add up the sales of its previous months also, which is what this calculator is ideally doing. So I'll quickly walk you through on what this calculate does. I can even copy this code and share it on the chat window so that you can look at it. So this calculate is doing the sum of the sales amount, okay, where I'm saying that the date key that is there in your sales table should be between a range. should be from the 1st of January of that year till the last date of that particular month, right? So since we are doing a grouping by month, naturally the last date of every month can be 30th or 31st or 28th, which is what has been shown retrieved by this expression. And if I have any filters that are being applied on the dimension table, okay, it should also be removed when I do this calculate. So I'm going to copy this expression first, and this expression will be run on your star schema data model. Okay, so let's go back. Let's remove this and let's run this. Now look at how long does it take to execute this query. How much time does your formula engine and your storage engine take to execute this query? You can see that it was taking 42 milliseconds to execute, of which most of the time was taken by your formula engine and very less time was taken by your storage engine, because your storage engine is now executing 3 or 4 different queries. The first 3 queries are taking much less time compared to the last one. The reason is very obvious, because we are just trying to do a serial scan, okay, which is going to be on the date key, or it can be on the year or on the month, okay, or it can be to find the max date of the respective months. But this is the table which is what we are interested in, because this is the table that is going to give you the sales amount for every month, okay, based on total month to date. As you can see in the where clause, right, we are doing a match of the date key with these different numbers. What you see is the integer value of the date key, okay, but I just want you to ignore these numbers. But I just want you to focus on this aspect here. Maybe I'll just move this to the top so that you can read this. I just want you to take a look at it. So you can see that there are 1096 values that are being used in this date key, okay, in order to get the result that we need. Okay, so this number is naturally going to be on the higher end when we are using the same expression on the fact table. So let's go back. Okay, so it's the same expression that I'm using here, but since I don't have a dimension table in my other data model, okay, I'm using the date key or the calendar year, which resides within the same table for doing its purpose. Okay, so let me copy this first and share this on your chat window. Okay, so yeah, so the one that I just pasted is more for the star schema. The second one is more for your fat data model. So let's copy this and have it here. Okay, so let's run this. Now, as you see that now the time is automatically increasing. So this proves a fact that the total number of rows is also increasing. Earlier it was just 1000, now it has increased because it had to scan more number of rows and more number of columns in order to get the result. So coming back, the next benefit that you're having, okay, when you're having a star schema is naturally you are going to look at improving the speed of your visuals, okay, which means in a fat data model, okay, it needs to get the result. Whereas when we talk about a star schema data model, okay, naturally it does not need to do multiple scans. Rather, it is going to use more of relationships. Okay, okay. The next one that I've already focused on is more for reuse. Okay, so naturally when we talk about a fat data model, okay, reusability is bad, right? Because you will have only one table having all the fields. Whereas when you talk about a star schema data model, okay, reusability is always there. So I just want to highlight one important aspect, okay, which you can explore later also. So here is a star schema, which you have already seen. Now let's say that I want this product table to be used in Excel, which means I want to use this product more as a data type within my Excel. That is possible because I can use feature tables within Power BI. So feature table was been there in Power BI for a very long time, predominantly for users who are using Excel and want to look up their data, okay, by using the key field here. So now let's take this example. So I am having the dim product. So I want to mark this particular table as a feature table. So I'll just say that this should be marked as a feature table. Okay. So I'll say that this is product table with attributes. Okay. So I just need to say in this particular table, which column will be used as the key field, which means it should be a unique field. So I'll just mark it as product key. The product label is the one that will be displayed when it finds a match. So for example, I'm going to have the product name here. Okay, so I'll just save it. So now the benefit of having this feature table is something that you will notice. Okay, once you have published this report into your Power BI service. So let me publish this and give a try. Hey Partha, I hope we are not running out of time. Can you?
No problem. No problem.
Yeah, okay.
Please go ahead.
Yeah. So I'm just going to publish this to one of my workspaces. So remember the product table was marked as a feature table with the product name as a row label. Okay, so let's remember that. So it's published. Let me verify this. I'll go back. My adventure. I'll make some small changes here. Please hold on. Okay. So here I have my star schema. So this is my data model. Okay. So now if I'm sharing this data model with others, okay, and they would be able to connect to this data model by using Power BI desktop or an analyze in Excel or even using XML data point. But there is also another side to it. They can use Excel data type. So let's me open Excel. Okay, so let me have Excel opened. So let me have a blank Excel workbook. So I've already connected to the same tenant by using the same credential. So I'll go to the data. Okay, so now you see that the dim product is automatically being listed. So I'll select the dim product. Okay, so let's say I have the product key here. So I'll just have some product keys. I just need to go back to my Power BI desktop so that I enter the right ones. So 417. So let's say this is 416, 417. I just mark it as a table. Okay. So what I do is I just selected these two keys. Okay. I go to the data. I'll go to data types and say, I want you to find a match of these keys by using the dim product feature table or data type. So let's select it. So now you see that it automatically connects, okay, to my data set. Okay, and it is giving me the name of that particular product. So let's find out whether the name of the product matches. So this is the name of the product that you find here. Now the benefit of having this the Excel data type is you'll be able to add more related fields of that particular product. For example, I want to know the manufacturer, or I want to understand what is the size, or its let's say style name. So you can just add other attributes. As you see that even users who are not comfortable in using Power BI desktop, they would be able to connect to your shared data set and pull the information by using these Excel data types. Now, why are we talking about feature tables here? The reason is if you're having a fat data model where one table is having all information, naturally you know that this information that you see here will have too many columns. So this makes it quite unusable for them to use this particular data model, right? and hence I do that recommendation. Okay, great. Now the last one that I want you to focus on is easy to change, right? I'm sure all of you agree to this point. Because if you're having multiple tables, right, dimensions and facts, it's quite easy for you to make changes, understand the impact of this change, okay, across multiple tables. Another benefit of easy to change is, let's say that based on the metrics that you receive from your audits, right, they observe that the sales table, okay, is growing, okay, exponentially, and you would like to look at reducing the size of this data model, or you want to look at reducing the refresh time of this data model. We have the feature called incremental refresh. I'm sure all of you would have used it or heard of it. So at an imported table, I can configure an incremental refresh, okay, where I can say that on this particular table, okay, based on, let's say, the order date or my sales date, I can say that the last 5 years data or is an historical data, okay, the last 6 months data, okay, is the one that needs to be refreshed. Okay, so that rather than refreshing the entire table all at once, okay, you are just going to refresh only information of your sales table in parts. This incremental refresh can even be applied on one single table, okay, where you're having all dimension facts. But look at the amount of information that is going to be loaded when you do an incremental refresh, because you're also going to get information even from entities that doesn't change, like a date or a customer or a product. And hence, I would request you to think about it. So the next time when you're thinking of a data model, ask yourself this question: do I have tables of dimensions separately from your fact table? Otherwise, I would want you to look at denormalizing it or normalizing it. A normalizing is the place where I just talked about. A denormalization is also required in scenarios like this. Look at it. I have three dimension tables, okay, which are interconnected with each other. I was using this term called table expansion, right? I hope all of you remember that term, right? So we were talking about table expansion. So when I say table expansion, your product table is on the many side, your subcategory is on the one side, which means that when I am going to aggregate my sales based on, let's say, the product category key, naturally my sales table will do a left outer join with product, which in turn does a left outer join with my subcategory, which in turn does a left outer join with my category. As you see that there are three joins that are being performed, which means your storage engine will take more time to execute this query. So in that scenario, it's often better you denormalize your dimension tables, which means that you can bring certain specific attributes of your product category, your product subcategory within your dim product, so that you are having only very few dimension tables, okay, surrounding your fact table. Okay, so let me pause here for any questions that you're having about the two types of data modeling that I focused on. I'll just go back to my chat. Yes, Imad, you will be receiving the recordings. Yeah, I'll just give you a couple of minutes. Okay, so there are some resources that I want you to look into. Okay, these are resources that are already being mentioned as a part of these webinars and the meetups that pages that you have seen. Okay, but I just want you to look more from, I would say, a star schema perspective, more from a DAX Studio perspective, so that it's not just designing a star schema is good. You should also ensure that you are testing it, okay, as you start designing it. Okay, so just try to see whether you are having a regular relationship between tables or a limited relationships, because a very common issue that I've often found is they have a star schema, but rather than having the filter direction, I'll just share my screen once again. So rather than having the filter direction towards the sales table, like the way you're seeing here, okay, they will change this to both. I'm sure some of you might have seen this. Okay, I would say this is a bad practice. Okay, don't do that. Okay, so when you're making it as both, okay, naturally you know that you're allowing the filtering to happen even from your sales table from your to your date table. So naturally you would want your dimension to filter your sales and not your sales to filter your fact. This is another common problem that you'll find when you're having one single table which is having both all dimension information, because the moment you're filtering by, let's say, the calendar year, it automatically filters the colors of the products also, because everything is part of the same table, right? So you will not be able to know the list of colors of your product, because the fact table, which has all information that we are talking about, will have only products or year where we made some sales. So naturally, you will not have the information of products or the date where we did not make any sales also. So that's also another bad design, okay, that you need to consider. So here are some information that I want to share it across, okay. So if you want to reach out to me, okay, if you have any questions on what we have discussed today, please feel free to contact me. Okay, I'm available in LinkedIn. You can search for my name, B Sai Prasad. Okay, and ask your questions through that. Another information that I wanted to share with you is I already have a blog post on it. Okay, so it will have weekly or bi-weekly updates on new changes that are happening with respect to Power BI. I want you to closely follow it if you're quite interested to learn more about Power BI. Okay. The third information that I wanted to share is I already have a YouTube channel. Okay, so I'll just show you that. Okay, so this YouTube channel is only 3 weeks old. Okay, so you'll not have much videos here. Okay, but these videos are something that comes from my own experience in terms of something that was very difficult for me to learn about Power BI. Okay, I've just recorded it and added it here. Okay, so that you can start learning more about these interesting concepts. Okay, so let me stop sharing and let me give you these links. Okay, so let me stop sharing here. Okay. So any questions, you can unmute yourself. You can ask me some questions if you have.
Meanwhile, even I'm sharing the links of today's learn module, which can take your learning further. Yeah, share those links as well.
Hey, thanks, Partha.
Yeah, as well. Again, also would like to share few more links. So the first one is our Reactor LinkedIn group link. The second one is our Reactor meetup link, where you can find our more sessions which are being published for coming November and December. The third one is our Reactor YouTube channel link. The session will be uploaded within 72 hours. So I patch up the recording and everything. Yeah. So
So
any
any
more
questions,
questions?
Partha? Yeah, just wait.
Questions?
So if you don't have any questions, I just want you to take another 1 minute. Okay. Can you please share one key learning from today's session? What is your key takeaway from today's session? Please use your chat to send a one-liner. Okay, thank you, Prasad. Thank you, Praman. Thank you, Imad. So as you're listening it, okay, I just want to highlight some important points on what we have discussed. Okay, so we said your dimensions are business entities, whereas your facts are going to be measurements by time often. So they are connected through relationships. So though there is a relationship cost when it comes to executing queries, when you are having more of complex DAX queries, right? Naturally, these queries are being relationships are being offsetted by the cardinalities and the list size of your data model that we have often seen there. Another benefit of using the star schema is quite easy to reuse that. You can mark it as featured tables and share it with others. It's quite easy to change and maintain it. And your data model size is also going to come down, okay, when you go for a star schema. So irrespective of where your data comes from, remember Power BI is not a visualization product alone. It is a data modeling engine. So if your data model is good, your reports will be very fast. If your data model is bad, your reports will also be quite bad because your reports are going to read data from your data model only. So on that note, okay, so we are closing today's session and I hope that this webinar was quite useful to you. Please share your feedbacks either to Parath or to me through LinkedIn. Okay, I'll be happy to hear them out. So once again, thank you everyone and have a great day ahead.
Thank you. Thank you everyone for joining us today. Thank you, Sai, for your valuable time for us. Please use the learn modules. It will take your learning further and enjoy the rest of your day. Thank you so much.
Is there a survey link they need to provide? I don't know.
It's okay. Yeah.
Okay, yeah.
Let's
Hey, thank you, Parath.
stop the recording.